Hello guys, I'm Nirazan. I'm uh, officially I'm kind of a software developer, but recently I'm thinking to apply for some government papers, and I came across the positions like assistant director and like the different level of it. Um, so for paper one, I kind of saw the syllables and made it like a summary, like phase one, phase two, and what to do for each weeks. And for paper one, these are the syllables, and for paper two, this is the thing required. And paper three, like we have to launch some act as well, like electronic act, ICT guidelines, and there's like e-commerce, e-governments, and AIML. So for starting with paper one, I'm thinking about like really teach in much more um, easy way, uh, like in a much more like simplified way, so that um, we can have like you can understand it properly. And like I haven't like got that much resources as well for this examination, so I was like, let's not why not like kind of create a tutorial like playlist for this paper, right? So for one Newman in Harvard, starting with computer architecture and microprocessors. Let's start with that. So of computer architecture, there's like CPU here and memory, and there's the IO device, and this is the CPU as a whole. So we are just talking about the architecture of CPU, how the CPU communicates with another component for getting the data. Similarly, like there is also the same kind of thing happening in the hardware architecture. Basically, like there is two types of architecture mainly. So this is the two architecture, which is von Neumann and Harvard. And I have also like tried to like have a good note for this paper one, so that you can look into it one by one, right? So I'm thinking about sharing it too, but let's see what happens. One Newman, there is the memory where our data and instruction is kind of placed in one place, where in hardware architecture the memory for data is separate, and the memory for storing the program or instruction has a separate component. Um, the bidirectional bus, the communication flow that you can see here, is um, the data bus, and the CPU has unidirectional uh, flow right to the memory. So this is address bus, and for controlling the sequence of these operations, we have um, a unidirectional um, bus as well for this, which is control bus, which is not like shown in the figure, but it's actually there. So um, for the hardware architecture, when we can see like the address bus for data memory, and the program memory has like different buses separate for ease, and pro like data memory, there is the bidirectional data bus, and you can see like a unidirectional flow from the program memory to the CPU, right? So we will talk about it. For von Neumann, you can see whenever we need data as well as instruction at a single time, then those data and instruction have to travel from the single data bus. So the time to get those data and instruction at a single point of time is slower as compared to the hardware architecture. And what is the use of address bus? Address bus, like you may like get really confused for this, but um, before diving into it, I will like I think I should start from the very beginning that um, uh, for suppose I kind of like um, suppose I have an instruction which is print von Neumann, and another in another code I have um, maybe like print something like this string, right? So firstly, those two instructions um, is present in one file. Let us consider that is um, let us consider that is like um, the program dot maybe like dot c file, and um, first that is loaded into the memory, a single point of memory, and the single memory has like the memory will at one line we have print von Neumann, and another line we have print something. So a print um, von Neumann has a memory address of 1001, and print something could have memory address of 1002, and we have to like altogether execute the whole file. So the CPU won't directly get the all file into a single request. What it typically does is it will first um, have a 1001 address, and it will kind of request this, and it will return print for Neumann, and it will execute it. And there is a program counter which is a register inside the CPU. After executing it, the previous address which was like 1001 will be in with it will like program counter will increment that by some value. In real cases, it could be 4 byte, 8 byte, or 15 byte, depending upon the computer architecture, like 86 architecture, 64, or something like that. And what it does, the CPU will read the value of program counter, which is like program counter upgraded itself after knowing that control unit actually decoded the instructions, the previous instruction, and then it will ask the memory for the data which is print something, and that's the flow. And remember, we have also the control unit, control bus, sorry. um, that control bus is responsible for the different type of signals. Suppose we may have read operation signal for only reading, or write operational signal to do the modification inside the memory, or making a synchronization, a timing synchronization sort of thing. So that will be done by the control bus, and yeah, that is the overall flow. So the address is actually for getting the instruction bundle at a time, not we're not getting every, like we could have a, maybe like thousand of code, thousand of instruction to process. So for that we should have a mechanism for getting the code in like chunks. So that kind of flow is maintained by the address bus, CPU. Altogether they are working in a combined form. Like, yeah, the address bus is unidirectional, data bus is bidirectional, and control bus is also unidirectional. Um, in Bone Neuman, we have one memory plus one bus, so it is bottleneck as compared to the hardware architecture. Um, I've also like tried to simplify in a Nepali words of a microprocessor like data science, so like program. It asks address bus, it get data asks gets through data bus, control flow happens through control bus. So yeah, for a hardware architecture, I've already explained that. Um, so hers, which is the operation per second, so billion to gigahertz. You have to remember that is a billion parameter, billion operations per second. So there are multiple equations which of the best describes control bus. I've already explained that. Um, like timing and control signal, right? And describe the complex sequence of the sequence. I've already explained that as well, and I think I missed this one, which is whenever we put the address into the address bus, we are also um, saying the signal, like read signal or write signal from the control bus. So on the basic memory will retain the value. So if there is the right operation, then memory will um, give us the right permission to do the modification inside the memory addresses, values, right? So and memory places instruction data to the database. CPU receives the instruction to database and executes it. And again, CPU again places the address of the next instructions set by the program counter. So for conceptual understanding, like yeah, in another video I will try to discuss the register in more detail. Program register, instruction register, memory address register, and memory data address. For now, like for Neumann and hardware architecture is sufficient, I guess.